Jarrah seems to be very concerned that moon rocks contain oxides, and yet scientists say that moon rocks show no signs of oxidation.
We already know that any scars from re-entry would be absent after the materials were retouched in a ceramic slab. And it is simply false to say that the Apollo lunar samples show no signs of oxidation. Obviously, how can moon rocks be composed of all these oxides and yet not show signs of oxidation, as is claimed by propagandists and certain other geologists? But as demonstrated previously, the rocks do contain water and do show heavy signs of oxidation. How can the moon rocks be composed of God only knows how many oxides and yet not show any signs of oxidation?
I'm really not sure what Jarrah's point is here. He never comes right out and says that the presence of oxides proves that moon rocks are fake, so I think he's simply building a straw man argument to suggest that geologists are stupid because they can't recognize that the oxides in moon rocks are the result of oxidation. But, just to be thorough, let's examine the fallacy of both potential claims. Why do scientists say that moon rocks show no signs of oxidation when they obviously contain all those oxides? Well, let's say you expose a polished chunk of silicon to air, or better yet, pure oxygen, at room temperature for a long time. What happens? Eventually, you'll see a very thin skin of oxide, about 10 angstroms thick, form around the piece of silicon. On the Moon, temperatures range from minus 233 degrees C to plus 123 degrees C. Over that range, the oxide layer would not be any thicker than at room temperature. This thin skin of silicon dioxide is what most scientists refer to when they talk about oxidation. It's the formation of a secondary chemical compound appearing long after the chunk of silicon first formed. If you raise the temperature of the silicon above 600 degrees C in the presence of oxygen, a thicker layer of silicon dioxide will form. People working in an IC fab refer to this high-temperature process as growing oxides. Above 1650 degrees C, such as when the Moon and Earth were forming, silicon melts. Now, oxygen-16 is the third most common isotope in our solar system. Silicon-28 is number 8. So, like chocolate and caramel, they were destined to come together and do great things. When the Earth and Moon first formed, the silicon and oxygen that was present became a homogeneous molten magma. As this magma cooled, it formed silicon dioxide crystals, which should not be confused with the silicon dioxide molecules that might be found in some parallel universe. These crystals accumulated and precipitated out of the magma by floating or settling, forming cumulative rocks. Although oxides form during this process, it is called fractional crystallization, not oxidation. Silicon dioxide is the major constituent for all the silicate minerals present in rocks found everywhere in our solar system. For example, meteorites, especially chondrites, which formed in the atmosphere-free zone of the asteroid belts, are rich in silicon dioxide and silicate minerals. Jarrah knows that, and so I don't think he's implying that lunar rocks, or any extraterrestrial rocks for that matter, shouldn't contain oxides. If he is, then it's a bare assertion fallacy. On the other hand, if he's implying that an oxygen-rich atmosphere is required to form oxides, then that's a fallacy of necessity, simply because common meteorites contain oxides. There is also an absence of secondary minerals that would be present if NASA's moon rocks had been exposed to the Earth's atmosphere. For example, weathering would partially or completely replace the two major minerals found in moon rocks, the plagioclase and olivine, with chlorites, which are virtually absent in moon rocks. Weathering is also responsible for the formation of mica, a common hydrous mineral found in Earth rocks and meteorites gathered on Earth, but completely absent in moon rocks. And lunar rocks contain small grains of metallic iron, which is extremely susceptible to oxidation. If these rocks had been exposed to the Earth's atmosphere, all that iron would have turned to rust, or ferric oxide, which is also completely absent in NASA's moon rocks. So, apparently, Jarrah's concern over the oxides in the moon rocks is the result of his misunderstanding of the chemical processes involved in rock formation. Since the oxides in the moon rocks were there when the rocks transitioned from a molten to crystalline state, and are not the result of a subsequent exposure to any oxidizing agent, such as oxygen in the Earth's atmosphere, scientists know better than to say the oxides were formed by oxidation. And that means that all the scientists and geologists in the world are not so stupid after all. Lunar mineralogy isn't really that complicated. Let's just suffice to say that if a good apprentice geologist held an oxide-laden rock in his hand, they could figure out fairly quickly what process was responsible for forming those oxides. Ciao, moon hoax conspirators, wherever you are.